Okay, so good morning, good afternoon, and good evening to genetic enthusiasts around the globe. We have online with us today attendees from 41 different countries. So welcome to the Semex webinar. My name is Jay Shannon. I'm Vice President of Marketing and Solutions at Semex, and we're very happy to be joined today with Dr. Stephen Larmer, Director of Genomics and Analytics at Semex. Welcome, Stephen.
Thanks.
If you have any questions throughout the webinar, please use the Q&A icon at the bottom of your Zoom window, and we'll strive to respond to any of those questions before the end of the webinar. Today, Stephen and I are thrilled to be able to share with you some really exciting developments at Semex on the next generation of Immunity Plus. Today, we're going to show you the novel approach taken to advance immunity and why we can confidently say the next generation Immunity Plus is going to be the world's best health index, bar none. And you're going to see that our current Immunity Plus brand is best in the industry today already, compared to other leading health indexes, and then how we're going to take it to a whole new level, making the best health index even better. Immunity Plus has been a brand only at Semex, a brand on bulls, no publication of a immunity proof. And for genomic tested females via Elevate application, they've received one of 3 letter codes, H, A, L, for high, average, and low. Well, no longer. We will have full publication of immunity proofs on all Semex bulls and Elevate tested females. Breeders will be able to build immunity into their breeding goals and client indexes like never before, accelerating improvement in animal genetics in animal health via genetics. So I would like to describe the concept pursued in building the best health index. We started with immunity, the 2 adaptive immune responses, antibody-mediated immune response and cell-mediated immune response, and then a new component that Stephen's going to describe later called nitric oxide production, which has an impact of restricting the innate immune response or innate immunity, which is the animal's first line of defense. The immunity side involves precisely measured traits with very high heritabilities, thus building the animal's core defense mechanisms to foreign pathogens. When we introduced Immunity Plus 10 years ago, there were essentially no disease traits, just somatic cell, productive life, herd life, DPR, daughter fertility. But now there are disease traits offered from many sources. So the concept that we had was to take the immunity and take the disease traits that are offered from all the different sources in a blend approach of those disease traits to come up and find the best prediction of to maximize disease cost overall. So what Stephen's going to show us is how they took the actual disease data from on-farm data as our predictor set, and then all the genomic data on the disease traits and the immunity to come up with the optimal prediction. So we're letting the farm data show us the solution, the best possible results for animal health. So at this time, I would like to hand off to Dr. Larmer to take us through the outstanding research that has been performed. Stephen?
Thanks, Jay. So just to start off, a very quick method slide here, kind of to just show how we came to the index values that you'll see on the next slides. We took a much larger group of herds than 100, but we really pared down to 100 large herds that were representative of the global population that did a really good job of health recording, that had a large number of genotyped animals and were very consistent in what they classified as a case of each of these diseases that you see on the screen. And that's really important because we wanted to make sure that that we had nice, clean health data to start with, as health data can certainly be quite variable across herds. And so once we had this nice, clean data set where we had all of their health records for the last 2 years, you can see here in those 100 herds, we had a representation of just a little over 330,000 animals and over 65,000 genotypes. And for each of those animals, we averaged about 1.5 health event per animal. So 168,000 health events across, again, those listed diseases you see there. And what we were trying to do is really optimize an index that best predicted the least cost of disease for each animal. So we calculated a total disease cost for each animal in our data set based on the literature costs of disease from Liang et al. And this is the same literature that's broadly used, for example, in the CDCB calculation of their health traits. They've used that as their literature source for cost of disease. What we wanted to do is see, could we take, as Jay described in the last slide, our internal Immunity Plus evaluations, and could we blend those as accurately as possible with public health traits to create the optimal index, the optimal index being the one that predicts the bulls having daughters with the lowest disease cost. So what we did is we created a machine learning model that took all of those genetic indexes, took the health data and optimized those index values to create the best prediction of least disease cost. And the reason we used a machine learning model here is we don't know the exact genetic correlations. We don't know the exact biological associations between immunity and those specific disease traits. But what we want is to combine them in a way that's most powerful to predict disease. If all we do is use disease cost, or we know how frequent each of these diseases are, we may be double counting where we have traits that are highly correlated with one another. And we may be undervaluing other traits that may not be as well represented in that kind of model. And so by using a machine learning model, we can automatically account for all of those correlations that are happening, under the hood, behind the scenes. And so once we'd done that and created a model to predict the optimal association with disease cost, we wanted to compare it to our current immunity, and then we also wanted to compare it to kind of the two primary health indexes out on the market, the wellness trait index from Zoetis and the health trait index coming directly from CDCB, to see how our new index compares to those models. So to start, you can see here the weightings of the different indexes. So our current immunity is 65% based on the antibody-mediated immune response, 34% on CMER, and 3% on that new nitric oxide piece that Jay talked about. And I'm not going to go through these one by one, but you can see the weightings of wellness and the CDCB health trait indexes and how they weight the different individual health traits that compromise those indexes. And then you can see at the bottom here the optimal immunity plus, and the optimal immunity plus has still the strongest weights primarily on those main immunity components, on the antibody mediated and cell mediated immune response components, but also fairly significant weights on mastitis and metritis, and then some small weights on some of the other disease traits. For your information here, we also did consider a number of other public health traits. We considered livability traits. We considered some of the reproductive traits, daughter pregnancy rate, daughter fertility. But in that optimization step, the weightings of those traits always came out to 0. Same as you see here, the weightings of DAs, respiratory disease, and milk fever, those came out to 0 as well. That doesn't mean that those diseases aren't important. It just means that because of the correlations of other traits and because of the power of the core immunity traits, those things are already well taken care of by selecting for immunity and by selecting for these other public health traits alongside. So then obviously the big question was how does this index perform? How do we do relative to these other indexes? And you can see the 3 current indexes here. You can see, as Jay said, we already felt like we had the best index in the industry. And you can see here when we look at total disease, weighted by the prevalence of each of these important diseases, we were already outperforming the CDCB health rate index. We were already outperforming wellness. but we weren't necessarily the best across the board. And some of the differences, from trait to trait are more modest than we'd maybe like in a truly optimal scenario. And so we wanted to take the power of wellness and the power of the health trait index and combine them into the already incredibly strong immunity product. And when we do that, you can see what comes out. You can see the power of our new optimal immunity index going from 18% reduction in mastitis up to 26%. A slight gain in lameness, a trait that Immunity Plus already did an excellent job for gaining, compared to the current Immunity Plus across all traits. And when we look at total disease going from 21% reduction up to 28%, a really significant advancement compared to what's already out there, and significant decreases in every trait we looked at here. So really, really powerful. And then finally, we wanted to look and say, okay, how does it perform on the genomic side as well? So we took and we created the new Optimal Immunity Plus on all of our genomic tested females. And you can see, again, the results get even better. Mastitis, especially, and lameness, that, two of the really core diseases on most dairy farms, we have over 40% reduction in those two diseases from our optimal genomic index. So very, very significant differences and very significant disease reductions from selecting for the Optimal Immunity Plus index. And then one last thing before we take a little break and have some discussion here is we wanted to also look at what is this going to do? What is selecting for this index going to do across the whole population? So we looked at the proof correlations among our sires, among Semex sires, for the current immunity versus this new optimal. And what you'll see here is more favorable genetic correlations with almost every trait we looked at, with the broad indexes, TPI and LPI, with milk fat and protein, and certainly stronger proof correlations with the individual health traits, with many of those individual health traits being incorporated now into the new optimal immunity index. And the reason this is certainly a good thing is it means that selection for this index should be easier among elite genetic animals. It means more elite genetic animals are more likely to rank higher for this index as well. Certainly these correlations are not one, they're not perfect. And so there's still, a significant amount of value to be had from selecting for both, individual traits of value alongside this new immunity index. We're not, advocating this as a sole selection goal, but it's easier to select for, and it should mean genetic progress across a broader range of traits is much more possible with this new index.
Great, thanks, Stephen. And I think it's a good time for us to have maybe a little discussion on what we've learned from these. And Stephen has taken all that research and really condensed it into, and I think it was 4 slides. So there was a lot of information there. So one of the first questions I have is maybe a personal curiosity, but when we took the novel approach, there was a concept of what we thought was the right solution with the next generation immunity. And I guess my question for Stephen is, what was your initial feelings with the results? And as a follow-up question to that, why do you think this approach is so successful?
Yeah, I guess, Jay, we obviously monitor health traits very closely here. We've always monitored the performance of Immunity Plus very, very closely here. And so we've seen that there's value in Immunity Plus, and we've also seen that there's value in these public health traits. And so I was confident when we were combining them that we would improve over each of one or the other, but the magnitude by which we did so was a surprise to me. I thought we maybe would only make a marginal advancement over the current Immunity Plus, just knowing how well it's already performing. But seeing that almost step change forward in terms of the reductions in disease was surprising. It was obviously a very pleasant surprise, but just kind of, I guess, speaks to the power of some of the methods we used here. And this is a very novel thing, using a machine learning algorithm to develop a genetic index is not something that's been done broadly before. But obviously you can see the power in doing so here, because we get that significant step forward
That's great. No, I agree. And I mean, for me, similar, I don't know why I wanted to ask you and share it with the audience is how good are these results? And I think they're incredible that when you look at an impact of an Immunity Plus bowl and what that has in a difference and the magnitude of one generation, and then that high immune genomic female, and then that opportunity of making those female selections and the advancement you can make. Yeah, I think what we end up with is almost a magic formula in this. So my second question is, I was wondering if you might comment about the blending process of disease traits. So we had disease traits from CDCB, Lactanet, Zoetis, and rather than decide who's boss and who's more accurate or whatever, you chose a method of blending the mastitis for the three to come up with one mastitis and each of those. So why was that approach maybe helping to the optimal index, do you think, to make it more accurate in resistance to disease?
Yeah, it really, I mean, the method itself is very simple. We take the average. We blend whatever sources we have for an individual, and for most of our sires at the very least, we'll have all three of these. We'll have all three of these sources of data. We blend them equally because the theoretical reliabilities of them are all very, very similar. But I do think that blending them does help, and it's because none of them are perfect. None of our disease traits are perfect. We know that they're based on on-farm data, which is inherently often flawed, and inherently very, very hard to work with. And so none of them are going to be perfect measures of the trait they're trying to measure. They're all valuable. I'm not trying to say they aren't. They're very, very valuable. But the average of the three is likely a better representation because we're harnessing all of that data. We're harnessing data from a larger pool of herds by grouping them together, and a larger pool of environments as well, considering the differences in environments of CDCB herds, Lactanet herds, and Zoetis herds. We're ensuring that we're talking about resistance to maybe a broader group of pathogens and pathogens in different environments as well. So it ensures that if we have an outlier for one evaluation, that outlier is not being overused in the index, and it's being brought back to the mean by evaluations from the other two sources that may be more moderate and might be more accurate.
And to share with people Stephen and I have quite a bit of experience working with disease data. And it's what he's saying is valuable traits with a lot of noise in them. Farms that maybe don't diagnose consistently farm to farm, maybe consistency of collection. All of a sudden, when they have a problem, they really collect the trait, and then after they don't collect it so much, and it creates a difficulty, we'll say, for a genetic evaluation. And then by combining them, I think you're trying to reduce that noise and get closer to the pure genetics that are there, which we think is part of the reason for this success here. My third question: lameness receives only 2% weighting in the optimal index, yet the reduction in the number of cases of lameness is 31% for the daughters of Immunity Plus bulls, and 41% for high immunity genomic females. How is that possible?
Really, the short answer is we've always seen that Immunity Plus, the core immunity traits, AIMer and CIMer, do a really nice job with immunity on their own. So we still have those strong weights for antibody mediated and cell mediated immune response in our index, and they do a really, really nice job of selecting against lameness. And then the secondary piece of that is that the pathogens that are causing lameness are quite similar in general to the ones that cause mastitis. At least bacterial lameness, when it comes to the most common causes, you're still talking about E. coli, you're talking about Staph aureus, two of your main mastitis pathogens, and we have a significant weight on mastitis already in this index. And so what those specific health traits are bringing to this index, maybe that is not already covered by Immunity Plus as it was before, the antibody mediated immune response piece, is the ability to recognize those specific pathogens. By selecting directly on mastitis, we're automatically making sure we're breeding animals who can recognize E. coli, who can recognize Staph aureus when those bacteria are present. So if we breed for mastitis, we're going to see a a bump in lameness, because what we're breeding for at a biological level is the ability to recognize and respond to a specific pathogen that causes those diseases. And whether that pathogen is in the udder or it's in the hoof, the immune response being, across the whole body functions very similarly.
Great. And I guess similarly, and just to pull out the displaced abomism, because it's weighted a little bit high in one of those industry indexes. And it had no weighting in our optimal index. And I'm supposing that it might have some relation to the frequency and cost associated, possibly. But I also see the new index still does a pretty good job on reducing DAs. So I guess is the explanation similar to lameness in terms of not weighting DA, or?
Yeah, it's kind of both things you touched on there, Jay. DAs are not very frequent in the data set. They're very costly. So when they are there, they do get a significant weight in terms of our cost-based model, and that's why we use a cost-based model. So we account for diseases like this that are less frequent but can be very, very costly. But when we were going through this, I was very frequently looking at the known genetic correlations of these individual disease traits, and when you dig into that, you'll see that DAs have a very strong genetic association with both ketosis and metritis, and metritis gets a pretty hefty weight in our evaluation here. So my assumption here is that the metritis trait is doing a really good job of kind of that metabolic health piece that would affect DAs so much, due to that genetic correlation between those two traits. And I think that would be a big piece of it as well.
And to follow up with metritis, because we could see in the traits that it's the weakness of the current immunity, where the immunity plus bulls actually had more mastitis than the non. So I'm thinking that it is something to do that the body's resistance to metritis differs in terms of adaptive immunity that covers other diseases that immunity has covered so well across a broad base of disease. Is that what you would interpret? And I suppose it demonstrates the powerfulness of the approach we've taken, that makes sure that we maintain a broad base of defense against all disease by just the simple fact of the approach we've taken.
Yeah, and this is a bit of a tricky one, Jay. I think there's maybe a few things here, and I'm speculating, but I do think that it may be somewhat we've selected for immunity within Semex, and we end up selecting on specific bloodlines, and if there is a specific disease epitope, the ability to recognize a specific pathogen for metritis that's missing, and that we've amplified to some degree in our immunity lines, then that might exist through more than one of our immunity plus bulls, and that may be why we see that deficiency in our current immunity lineup. By bringing in the public metritis traits, we're able to flip that, and that's exactly the power of this approach, is that where there may be shortcomings in any of these disease traits, we're able to counteract that. And I really think that that's part of the power of the methodology we used here, is ensuring that we're taking the best parts from immunity, and we're taking the best parts from these public health traits to create this next generation of immunity that is going to bring the best parts of everything that's out there. And as you said at the start, ensuring that we are delivering the best possible genetic selection index for health that we possibly can.
Excellent. And the final one, and you covered it a little, but I think it's worth reiterating, relates to trait correlations. The new immunity index has much higher correlations with disease proofs, with functional traits like productive life and fertility, with overall total merit indexes like TPI, net merit, LPI, and pro dollar. Any explanations, and how is that a good thing?
Yeah, I guess the explanation as to why it's like that is because by adding in public health traits that are generally, across the broader population, more frequently co-selected with those indexes, because they're not just being selected in the Semex population, they're being co-selected across a much broader population, we're going to see higher correlations. And we're talking about some of these indexes, the traits we're adding are in those indexes. We have health traits directly in those indexes, so we expect to see higher correlations. The positive thing that really comes out of this is the stronger correlations with individual traits like milk, fat, and protein, and individual reproductive traits that we know have such an economic impact on farm. And really what it's going to mean from a how is that a good thing standpoint is that there will be more bulls that we are confident will provide this broad, robust immune response that will also produce more milk, that will also be more reproductively favorable than what's been there in the past where the trait correlations weren't as strong. So we can still get the benefits of immunity plus, but we'll see it in a stronger genetic pool of animals. That's not to say that every high genomic individual will come with these immunity traits as well. And that's why it's important to, as you said, start to put these into genetic selection indexes that we're working with clients on, and ensure that we are putting the appropriate weight on immunity alongside those other traits so that we make sure that we're co-selecting in the right way and getting the best overall economic benefit for our clients.
Great, and that's my questions for this part. And so Stephen, our next step is we are wondering of taking us through and reminding all of us the power of immunity and taking us through the concepts of immunity in your next section before we go on to some calf immunity components there. So I'll hand it back to you.
Excellent, thanks, Jay. So just to prime this discussion, I'm going to go through fairly quickly here the three types of immunity, and these are kind of the three main broad branches of the immune system. We have adaptive immunity, innate immunity, and passive, and I'll go through each one of them in the future in these next few slides. So to start with, we have adaptive immunity, and adaptive immunity is really the core of our current Immunity Plus offering since 2012. This is really the main thing we've been selecting on with Immunity Plus, and to some degree, it's the main component of immune selection of the public health traits as well. So adaptive immunity is primed by the innate component. We're kind of doing these backwards a little bit, and I'll get into what the innate component does, but we need an innate immune response to have an adaptive immune response that follows. But the point of the adaptive immune response is really its ability to recognize a broad range of pathogens, respond to them, and then remember them on subsequent exposure and build that stronger, faster immune response over time. As the immune system strengthens, it's really the adaptive immune system that's able to build on itself, continue to learn, continue to provide stronger and stronger and faster immune responses so that subsequent exposure to that same pathogen do not result in a clinical case of a disease. And those, that memory is specific to the pathogen, and it is long lasting, meaning that it will, continue over time, and animals don't necessarily lose it, or at least not lose it fully over time. So there are two kind of key branches to the adaptive immune system. We'll start with the antibody-mediated immune system, and this is really the part of the immune system that's primarily responsible for fighting bacterial infections. So bacterial infections happen outside of the cells, and the antibody-mediated immune response creates antibodies that are built to fight off those bacterial cells. And those bacteria, they're large living creatures, and they generally are more common, but I would say, generally slightly less costly diseases on farm. Your mastitis, your bacterial pneumonia, your general bacterial lameness. So things that are maybe a little bit easier to treat, but certainly the things that are most prevalent on your average dairy farm. On the other side, we have the cell-mediated immune response component that's primarily responsible for fighting viruses and mycobacterial infections. And so these are things that invade and attack from inside of the cell and replicate within the cell. They're attacked primarily by macrophages. They're small, they're not cellular. These are things that are generally less frequent, but when an outbreak happens, can be much more severe to herd health and can spread very quickly. These are your leukosis, foot and mouth, yonis, but also responsible for viral pneumonia, especially in calves, and then things like TB and retains, can be involved in the pathology of retained placentas as well. So next, we're going to talk about the first line of defenses, and this is what we call innate immunity. And that innate immunity is really the first thing that's triggered. It's responsible for recognizing anything in the body that's not self, and basically telling the rest of the immune system that invader is here and that we need to prime an immune response. There's no memory to past exposure of pathogens. It's not specific. It's not long lasting. It's really the alarm bell to some degree, and it initiates that immune response. Now, there is one other piece of the innate immune response. So what I'll say here is that if we select for the adaptive immune response like we always have, we know we're getting most of the broad innate immune response. Because if we have an adaptive immune response, that means the innate immune response must have happened. It must have primed that adaptive immune response. But there's one other thing the innate immune response can do, and that is, in some cases, it can actually kill off the pathogen itself. And there's certain parts of the innate immune response that are crucial in that ability to actually kill off bacteria and viruses before it ever gets to needing an adaptive immune response. One of those key pathogens is something we call nitric oxide. Nitric oxide's been shown to be a critical component of immune response. It is also involved in that priming of the adaptive immune response, but it itself is cytotoxic, meaning that it can kill off bacteria and it can kill off viruses on its own. On the human side, it's been shown to do a lot of things: control tumors, autoimmune processes, as well as play a role in avoiding chronic degenerative diseases. All that being said, is what's really novel here is we're able to capture with this nitric oxide component that ability of animals to kill off those small bacterial and viral infections very, very quickly before we ever even need an adaptive immune response. And the University of Guelph, and Dr. Bonnie Millard's group have worked on a method of measuring nitric oxide response in vitro, and then doing really nice genetic genomic association work where they found a number of SNPs that really, really strongly explain that biological pathway that can tell us how capable an animal is of producing nitric oxide. And it's very, very highly heritable because it's a fairly simple biological pathway and it's explained by a small number of SNPs. And so because of that, we can make really strong selection for it very, very quickly. What you'll see in the population that we've studied here is that across most of the population, there's not a lot of differences in how animals perform from a disease standpoint, depending on how much nitric oxide they perform, except for we have a certain number of animals who have no favorable genetic alleles for nitric oxide, meaning that none of the genes in that pathway are doing the right thing. When that happens, what we see is animals who are severely, severely immunocompromised. And you can see on the right side of this screen, the differences in disease of those animals who have no favorable alleles for nitric oxide. They have 46% more mastitis, 41% more metritis, 78% more lameness, 89% more ketosis than their herd mates who have at least one, anywhere between 1 and 6 favorable alleles in this pathway. And so it's, again, a fairly simple test in the sense that it's only 3 SNPs, but the power of avoiding those animals who are immunocompromised is really, really strong. And so, it's only a small part of the population that's affected, but by putting it into our immune index, we can really help breed against those individuals who are immunocompromised and really help our overall disease resistance as a whole. So now that I've gone through the individual pieces of immune response, and I'll get to passive immunity in a moment, I just wanted to highlight some of the other really, really positive benefits of Immunity Plus and some of the reasons why it's so important that it still gets a strong weight in our overall index. And these are things we're not sacrificing by going to an index approach from the traditional immunity approach. And the first is that it's highly heritable. And when we talk about those individual immunity components, and for those of you who have been paying attention to Semex materials over the last 10 years, we've been advertising a heritability of 30%. When we put it into the index with the public traits that are slightly lower heritability, the heritability stays very, very high. We're still at 22% heritability. And because there's so much data behind those public health traits, we're not sacrificing reliability. We're not sacrificing the reliability on the sire side. We're not sacrificing reliability of our genomic tests. So even though the heritability may be going down slightly, our reliability is just as high, meaning that our genetic progress should be just as strong or even stronger than it's been in the past. And when we compare that 22% reliability to individual health traits, or even to most of our reproduction traits, we're significantly higher. And that really comes down to a trait that's much closer to biology. And the closer a trait can be to the biology of the animal, the higher the heritability, because we're taking out all that environmental noise, the differences in management, and we're truly selecting for a biological change instead of trying to select for an outcome and hope we affect biology. When we select directly for biology, we make faster progress, and that's why we have a higher heritability. One of the other benefits that we're going to continue to see with immunity is improved vaccine response. When we select directly on that adaptive branch of the immune system, we expect better vaccine responses, animals that will respond better because they have a stronger memory component of that immune system, as I've described prior. And then finally, getting to the last branch of the immune system, we can talk about passive immunity. And this is really those first crucial days of the calf, and how they ensure that those calves get off to the best start. It's passed from the dam to the calf through colostrum, and it's going to fade as that animal gets its own immune system to replace that. But the nice thing about Immunity Plus is we're also passing on that higher quality colostrum. Animals who have a stronger antibody-mediated immune system produce more antibodies that are circulating in their blood, and those antibodies that are circulating in their blood will get passed into that first milk, into the colostrum, and give those calves a better start. So you can see here, animals, those high immune response animals, as we've tested them, and this is a study back from 2000, consistently higher levels of specific immunoglobulins all the way out to week 6 after calving. And when we look again, much more recently, a study in 2014, and we have more follow-up studies that are just being published now, showing the same things, that those high immune responders have more total beta-lactoglobulin and more total immunoglobulins in their colostrum compared to average or low immune responders, and that will continue to be the case with the new immunity index as well. Something we realized, though, as we built out this index and created an index to maximize health of cows, we started to look at how it would perform on the calves, and we started to see that by including all those public health traits, we were watering down the ability of these animals to respond, or the ability of calves to respond to disease. If we select only on the cow health index, we were disadvantaging calf health. And they are two different things. And if you look at the genetic correlations of calf livability, or any of those calf health traits with the cow health traits, the genetic correlations are not super high. There is difference in how a cow immune system functions versus a calf's. And so we need to think about them differently. And so what we set out to do was create a calf immunity index as well to go alongside, because one of the cores of Immunity Plus is we've always heard and we've always seen in our data that it performs incredibly well for calf health. Calves have been much more resilient. They've had less diarrhea. They've had less pneumonia. And so we wanted to ensure that we could still, provide that advantage to clients as well who want to select for healthier, more robust calves. And so we went through the same process, weighting the individual immunity traits, AIMer and CIMer, with the publicly available health traits. In this case, we're just talking about Zoetis traits. So Zoetis calf respiratory and calf scours, as well as heifer livability. We considered Zoetis heifer livability as well as CDCB heifer livability. You can see here, they didn't receive any weight when we went through that optimization process. But you can see the difference that we're able to make in calf disease from the new optimal calf immunity. And you can see here there's kind of two slightly different variants. On the Elevate side, we don't have those Zoetis traits, and so the optimal immunity plus will just be made up of the core immunity traits as they've been measured from the start. But you can see here those optimal indexes are outperforming our current immunity plus, and so there is a slight reweighting of the immunity traits themselves for this calf immunity index, and that does increase our reductions in disease for calves as well. So what you will see at proof time is two different evaluations, one for immunity and another one for calf immunity, and this is the results from the calf immunity index. So finally, and I won't spend too much time on these next two slides, we wanted to look at the potential economic impact. And so what we did is we took the disease reduction that we see in our population from the optimal index, and then we looked at, if every herd or the average herd has that reduction in disease, and we looked at population frequencies of each of those diseases from the National Animal Health Monitoring Service, the most recent one in 2014 now, but looking at those population disease frequencies, the cost of disease from literature in first and subsequent lactations, and we looked at what is the savings, assuming an animal lives to 2.8 lactations, which is the current average. And so by doing that and summing that all up, we get for a high immune animal, which in this case is an animal that's 105 or higher in the immunity index, we see an expected lifetime savings of $147.45. And when we calculate that back to a per point basis, we get $23 per point over 100 that you'd expect that animal to be worth over their lifetime. I will note here, it's on the slide, but the other component that was included here looks at the calf disease piece, the vaccine response effectiveness, and the value of that higher quality colostrum when it comes to the expectation of fewer diseases in the first days of a calf's life as well. Did the exact same thing on the genomic side, so I won't get into any of the numbers on this slide, but because of the greater reductions in disease on the genomic side, we see that value increase for a genomic female who tests 105 or higher at $217 compared to an average animal, who tests at 100 exactly. And when we calculate that back on a per point basis, we're looking at $33 per point over 100 of value. So with that, I will pass back to Jay to summarize some of these changes as it pertains to our bull lineup.
Great, thank you, Stephen. And so I'm going to just show us what happens with Immunity Plus bulls. And we know in the past, once awarded Immunity Plus, a bull always maintained its Immunity Plus. It never lost its status. That's how we operated with the Immunity Plus. So now we're looking at a system where it's run every round, and bulls will have a new evaluation and may add or have their immunity taken away. So we want to look at the impact of what happens versus the current immunity to the Immunity Plus with the optimal index. So we just looked at and pulled 940 active bulls, which are proven fast start, and Genomax and marketed bulls within Semex's group, and there's 940 altogether. To give us a percentage of the current immunity is about 25% of them are currently Immunity Plus. When we're selecting an Immunity Plus, typically currently today it was somewhere around 10 to 15% of animals by test. And so what it does tell you is bulls that get in our lineup, there's a favorableness to be an immunity, because those are the bulls that will sell a little more and will get to the market. So that's why that percentage gets upwards to 25%. When we run it with the Immunity Plus optimal index, our number goes to 311 of those 940 bulls, or 33% of the bulls would receive immunity. And when you look at the old, the current immunity, the 232, 142 of those maintain their immunity status. 90 of them lose their immunity status from today. And then there's 169 bulls that add immunity and that haven't had immunity before. The 90 bulls that are removed, 76% of them have an immunity index over 100. They might be bulls that have been immunity a fair long time ago. There's been genetic progress, different factors. Maybe they didn't do as well on specific diseases that come into the new immunity, and may have slipped in terms of the qualification for the Immunity Plus brand. But you can see a good portion of those are 104, 103, 102. The one that's 107, how could it be losing? And that would have a calf immunity less than 100, and that's why it would lose its index. 24% less than 100, and as low as 91. Obviously, in some of these cases, older proven bulls maybe again were had some problems on certain diseases that have changed their ranking and evaluation a fair bit from where it was before. Total in number of bulls that are over 100 is about 73% of our bulls in our lineup. And really that's a factor of our genetic selection. We've been genetically selecting over the past 10 years for immunity, and particularly with genomics. Really, it's been a part of a filter of selection right through bulls coming into stud and then bulls getting marketed. So Semex, when we say it's an immunity company, and generally bulls have immunity, you can see that 73% have above average immunity in our bull lineup. So and that's been due to our selection and emphasis placed on. The next generation Immunity Plus, it's coming in August. So we're the August proofs are only, I think they're 6 days away. What we're going to have is we're going to publish an immunity and a calf immunity index. So those two values will be published on all Semex bulls, and also all Elevate tested females will receive this new index starting in August proofs next week. Go ahead, Stephen. We're going to implement on a fixed base, something like the US proofs. We're starting with bulls born 2014 to 2016 as our base group. These will be published as you could see there on an RBV scale, where the 100 is the mean of that base group with a 5 standard deviations. So generally proofs that range from 85 to 115 is kind of what you're looking at. And then we would change the base when the US changes their base, so that people get used to kind of base adjustments at the same time. Important for a trait that we've seen lots of genetic progress for immunity amongst our selection. So it's important to move that base with the population as you do with other traits. So the next change for the US would be in 2025. Bulls will receive Immunity Plus when the immunity index is 105 and the calf immunity index is greater than 100. And bulls must requalify for Immunity Plus each proof run. So every proof run, we wipe out all the Immunity Plus bulls, rerun the evaluation, relabel all Immunity Plus bulls each proof run as we go forward. Just to give us some idea of what the sire proofs will look like. This is Pursuit's sire page, and you can see the part that's highlighted there that shows us the pronounced part of the immunity proof, and we put the calf immunity proof right below it to kind of keep them together. And for somebody like Pursuit, who's a really high TPI and LPI bull, proven bull in our market. He's a bull that wasn't forming Immunity Plus, and the way the evaluation is right now, we expect that he will be an Immunity Plus bull in coming next week. And then for Elevate, and there's various parts I'm not showing that are on the phone app that you can see, but the one part, if you just click another, Stephen, is the in all the lists and Excel files, you'll have the immunity index, the calf immunity index, and then you'll have graphs that are plotting the progress for immunity within the herd, averages for immunity and calf immunity, And these kind of things are the parts that are going to be value add components in the Elevate again to try to help herds make selection for an index that obviously has a big bearing on overall disease reduction and reduced costs on the farm. The immunity is, I want to reiterate the complete health package that it is. Obviously, we're taking at core this immunity, and then we're adding the power of all these indexes from all sources to take out the noise as much as possible and end up with the cleanest health prediction. So it really gives ultimate power to minimize disease through genetic selection like no other index in our industry. The defense that's robust and broad-based. What we saw was we now have a components of cows and calves to select for, viral, bacterial, mycobacterial. We can see that by the approach, it's going to cover improvement on all disease. It covers the innate immunity with what Stephen described as nitric oxide production that hinders that innate response, and the adaptive components combined is the power of the immune system. And then not only that, then these higher immunity females have higher quality colostrum. So we're creating that passive response as well. And then with the improved vaccine response that comes with a stronger adaptive immunity, it really is an all-around 360 complete health package for genetic selection that really will lead our dairy industry. So what I would say is we're extremely proud that next week we're going to introduce the world's best health index, the next generation of Immunity Plus, to the marketplace. With that I would like to thank everyone for attendance, for being part of the webinar. And we did have some questions, Stephen, that we will go through here. And I'll ask them, since most times probably it's going to be for you to answer, but if that's okay. Are you back on the screen? Yep. Okay. So the one question, and I guess this will be from me, is bulls from other AI companies will have immunity index now? And so the answer to that is no. This is a Semex exclusive that will be for only males that are Semex, and would not pertain to males from other companies unless something changed in what Semex, and there was some discussion with other companies. But it's a Semex exclusive for males on our bulls, and an Elevate exclusive for females. And through Elevate, there would be no males getting the value on Elevate for people that test on their males that way. The one comment question is, do you have some ideas why the old immunity was better at lowering retained placenta versus the new immunity? And Stephen, I looked it up, and the new immunity is actually better than the old immunity at retained placenta, but some of the health indexes in the industry, the two that we showed, actually had a slight improvement or a little bit better improvement than immunity. Is there any comment you would have there? I think what the part is ours makes improvement on immunity, and that was one of the traits that the industry index was a little bit higher, I'm assuming, to the way they weight or what they look at.
Yeah, I think it would just come down to the weighting of that specific trait in our index versus theirs, and it does get a smaller weight in ours than the public indexes. And at the end of the day, we selected on total cost of disease. And so retained placentas were in that model as part of it. And certainly they got some weight in that optimization procedure. But if we had put enough weight on retained placentas to be better than the industry indexes for that specific trait, then we would have lost elsewhere. And so really what we're doing in that optimal sense is giving it the weight it deserves across all those traits, and trying to select and although not quite as high as those public health indexes may be for retained placenta, we're still seeing significant reductions in retained placenta compared to population average. And so, we're very confident in how that all shook out. But yeah, the reasoning would just be that it didn't get a huge weight from an economic and a disease prevalence standpoint in that cost-based model, but certainly still got some weight and improved on where Immunity Plus was before.
Great. And the next question is, and we're going to go through them, and some of them maybe we've answered before, but just to go through them, the which diseases are included, and I think this is where your first part in the research, and you listed the diseases that were in the research of the 330,000 animals, was what's included in fertility and other disorders, and how are the costs of these calculated?
Yeah. So for fertility, it's mostly things like cystic ovaries. There's a whole list, and we work closely. I should give credit here. We work closely with a company called Data Dairy Warehouse, and they're the ones kind of cataloging those diseases on farm, or at least taking the farm data and providing us the cataloged data. So we're mostly talking about cystic ovaries, other reproductive disorders that are leading to infertility. And so when we're talking about that cost-based model, we're looking up the literature costs of the individual specific diseases. It's just for slide purposes here, where we're rolling it all up into one thing because we didn't want to inundate with the 100 different things we looked at there. Similar to other disorders, there's a whole broad range of things that could be. It's really anything that's not in that list. And then from a cost standpoint, we're looking at the individual thing if we can find a literature-based value for it, and if not, we're applying kind of a broad assumption of an average disease case of anything and applying that to those other ones. So that's kind of how we treated those in this process.
Great. This one is, if the average of the health index is used, and I think what they mean by that is the disease traits and blending the three sources, do all European animals have to be tested on TPI, or do they use the PA for these ones?
We don't actually even use the PA. Just from an accuracy standpoint, we'd much rather use what good data we have. And so if an animal is not tested on TPI, then the health traits will come solely from Canadian proofs. So if an animal got their Canadian proof, the health traits that are used will solely be those that come from Canada, just because the PAs are much less accurate. We don't want to blend in an even lower accuracy health trait in there. We'll use the good health trait we do have from the genomic evaluation of that individual in Canada.
And the next one is, I think for me, is how long is immunity exclusive for Semex? And I can say that it was, I'm not sure how many years ago, but not too many years ago, meaning just a couple. I believe Semex signed a 20-year exclusivity for Immunity Plus. So I think we have an outlook of, I think at least, I'm going to say at least 15 years of exclusivity of immunity, and with all the science that was done for immunity, it's a very hard to replicate for another researcher, is what often Dr. Bonnie Millard has said in terms of trying to replicate what was done in terms of the immune response research and system and patent that she has. The next question is, will the nitric oxide results be available through Elevate testing? Surely you don't want to breed replacements from animals that have zero favorable alleles for nitric oxide.
So I guess what I'll say there is in this first iteration in August, we've been working hard to get the broad indexes available. And so we're not publishing the individual traits, just like we're not publishing AIMer and CIMer. Certainly an animal who is very low for overall immunity will be more likely to be one of those animals with zero favorable alleles for nitric oxide. But what I will say is, stay tuned. It's something that we're working on, and beyond just the Elevate testing, what we're really working on, and the gold standard of something like this, where we want a certain number of favorable alleles, is a mating tool that will allow us to avoid matings that could ever produce one of those animals. And similar to how we treat haplotypes in a mating program, we're working on, on the back end, the technical details we need to incorporate that into our mating programs with Elevate results incorporated as well.
And as a follow-up, and Stephen, I made the comment before, is the zero favorable allele is an animal that's very I forget what you said, insufficient in nitric oxide production and in the innate immune response. Does and though the animal with, say, one favorable or two favorable may not have such a hindrance, or may only be slightly affected, or not even in comparison, it's only one or two favorable alleles away from being the next generation zero. So it, by nature, it's a trait that's important to us in a breeding trait, which is what I think you were trying to say there.
Yes. Yeah.
The next question is, as the August test, what is the range in which immunity 100 to 115 index will be handled?
So I think the question here is really just, what is the proof scale? So we're talking about an RBV. So if you're familiar with Canadian health traits as they stand today, or a number of traits around the world, a lot of global indexes use an RBV. That means that the mean will be 100, the standard deviation will be 5. In general, that means 99% of animals will fall between 85 and 115, but certainly we can have outliers outside of that range as well. But almost all animals will fall between that 85 and 115 range because of the standard deviation of the trait being 5, centered around a mean of 100.
Great. And the next question is, without genomic testing females, how many generations do you need to cross with immunity to have a herd with high immunity genetics? And so obviously, Stephen, I guess it depends, or you're going to have where that genomic level is of the females, and what are you starting with, and how many generations does it take to pull in essence, almost a parent average that way. But what's your comment?
Yeah, exactly. This is, inherently an impossible question to answer because of all those variables. But at the same time, it becomes easier if your goal is to breed for high immunity, now that you have the actual data on our sires to know exactly how high is a bull. And certainly crossing to a bull who is 112 will help you get there faster than a bull who's 106. And so it gives that power to drive your progress faster, keeping in mind that you don't want to sacrifice progress on other traits that are incredibly important. But what we're providing now is that power to fit it into a selection index. But giving a number of generations that all of your animals will be high is a very, very difficult thing to do. And like all other traits, the population shifts. So, like selecting for milk, like selecting for reproduction, you can put all your selection emphasis on it and you'll make a lot of improvement, but the population is improving as well. So, what we define as high is going to change over time as well. But the beauty of this is that there's a lot of genetic variation, a huge amount of genetic variation for immunity. And so we'll continue to make genetic progress for tens and hundreds of years, just like we have for milk production and reproduction in cattle.
Next question is good to give a further explanation. Is, it was not clear to me why we've gone from 30% heritability and it will decrease to 22% if the new index is better. If the new index is better, why did the heritability go down?
Yeah, and heritability, I mean, largely what we're kind of trying to say here is heritability is not the be all and end all. It is important. It's important to be able to make positive genetic progress, that we have a reasonably high heritability. But what also matters is the reliability of the trait. What also matters is the definition of what we're measuring and how it relates to the economic outcome. And so what we're doing here is finding a very, very happy medium between an incredibly high heritability trait and then some low heritability traits that are directly linked to the economic outcome of disease cases. And so the trait is better because it better predicts what matters on farm. It better predicts disease outcomes. And that's really the gold standard. The heritability helps us get there. The heritability helps ensure that if we breed for it, we're going to see it in the progeny. But if our trait, our initial trait is not perfectly linked with the economic outcome, then that's not good either. And so what we're doing here by combining these is finding that perfect medium, as you know, as well as our algorithm can do it, finding that perfect medium between our high heritability trait and the lower heritability traits that are really, you know, directly linked to the economic outcome of disease cases.
That's a great answer, Stephen. And the next question is, and we're going to try and get through them all. So will the threshold for immunity female status be similar to immunity plus bulls, 105 and 100? And I can probably answer that in the sense that we're going to release the two proofs for females, not necessarily categorize a bull for a female as immunity plus per se. Obviously, if you know the criteria, it would apply to the females as well. If you were trying to categorize a female that's high and a male that's high, Stephen, it would be the 105 and 100 for a female as well. But we're not necessarily branding the female per se, or plan to at this stage, just releasing the proofs for selection. With Immunity Plus being included on female side for Elevate, how much of a game changer should this be in a growing market of genomic testing? Well, Stephen, I think when you add something of this power, something of this influence, if we, what we're saying is the best health index in the world, well, I think it should be a game changer for selection. To some degree, wellness is that for Zoetis in terms of their genomic testing. And this obviously is showing an outcome that's better than that, and better in terms of what it can produce. So, I think it's a pretty big value add for genomic testing, and herds that have not genomic tested up to this stage. It's just another enticing option of saying, I generally might test my herd and get parentage and all the genetic selection of all the traits, and have sometimes a health selection that is difficult to accomplish without something like this. So, I would answer it by saying I think it's a really great opportunity. Is that good for you, Steve?
Yeah, I guess to me, maybe the biggest hindrance in how immunity has been packaged in the past is that I think for a lot of herds, when they want to select, they want to genomic test and make a selection on a single metric. And I don't think there's anything wrong with that if that single metric is a really well-defined herd index. The power we have now is that this immunity piece can very easily and very intelligently be incorporated into that herd genetic strategy. And should be. Given what we've presented today, it's very clear that it's a powerful piece of any herd strategy. And so that with that becoming the case, to be able to use that, if you incorporate this into your herd strategy, as we're recommending you should do, the only way to make selections on your females, accurately, is to genomic test them with Elevate.
And so how significant is the SNP on nitric oxide? It looks like an essential part of the new package to me. Are we the only one to license it?
So I'll start with the last question first. Yes, we are the only ones to license it at this point, and we have an exclusive license at this time. How significant is the SNP? There are a number of SNPs that we're using for that test, so it's not one. It is a number. But those SNPs explain almost all of the variants of nitric oxide production in vitro. So looking at how well an animal produces, or how well a cell produces nitric oxide in vitro, those SNPs explain almost all of the variants. And as I showed, the heritability of nitric oxide is incredibly high. And so in terms of explaining the biological variation of nitric oxide, the SNPs do almost all of the work. They explain almost all of the variants, and that's makes it very, very powerful for that specific component of the immune system, being able to predict it incredibly, incredibly well.
And if we'll follow on the nitric oxide, how far would you go so far as to recommend culling calves that have zero favorable alleles for nitric oxide?
And I guess that's really going to come down to each herd's each herd's overall strategy, their management. I'm not necessarily in a place to recommend culling of an individual animal. What I'm in a place to do is show you data that says we expect over its lifetime that animal will have 50% more mastitis. We expect that animal will have 70% more lameness than its herd mates. And that's the information I can provide. And I think that's valuable information that should go into a culling decision potentially. But again, those culling decisions can be broad based, because if that animal is an outstanding genetic animal otherwise, the smart thing to do there is breed that animal to an animal that's really high on this immunity index to ensure that their progeny will not be immune deficient and still harness the positive genetics that animal has for other traits. But if that animal is already on the borderline of being culled, well, then maybe it's a very wise decision to have that animal removed from the herd.
Great. To some degree, it's possible the animal will clear itself eventually. And do you want to make a preemptive decision on her? At the same time, as you say, some of these diseases that there's a higher percent chance, but they can be treated, maybe not be the hindrance, and maybe still be functional animals. So it's a like you said, an up to the individual really, and the individual animal often. Which breeds will this be available for? And then is there Jersey and Angus in the future?
So in terms of the genomic test, we're looking at Holstein only at this point, because that's really what we have a genomic reference population for. On the sire side, we will have these immunity indexes available for Jersey sires as well as Ayrshire sires. And in terms of the future, these aren't things I can say for sure, because there's a lot of research, there's a lot of testing, and there's a lot of things that have to be put into place to make this broadly available for another breed. But Jersey and Angus are both in our plans at Semex, but it really depends on those research projects and how they develop over time. So it's not something I want to 100% promise, but at the same time, they're absolutely in our plans here at Semex.
The next one asks, how soon will it take to incorporate the immunity index in the Klein index scores on Optimate? And so I'll answer that one, is with a coming solution that's going to be called Semex Go. And there will be a My Strategy component, and it's a total new Klein index evaluation that we're going to bring to the market in we'll say early in the new year. And that will involve, an index that carries through your Elevate and carries through your sire selection and obviously carries through your mating. And that would include the incorporation of an immunity index, the calf immunity index, and these components in. So that's for sure where it's going to happen. Doing it before then into Optimate is something we'd have to look at if there's any option, or we just put it on the course for when we're going to have the whole renewed system of strategy and Klein index with the new solution. The next question is, what does the economic impact cost of disease figures include? Just treatment cost or lost milk value as well?
The values we used include treatment cost, lost milk value, as well as the increased risk of culling or death of that animal from that specific disease. So it's to look at the economic impact of disease. We wanted to look at as much as possible the whole economic impact of disease. Now, I will say the paper we used is one of the more conservative papers out there. There are papers that have much more extreme health costs than this, but this is one that's really seen as highly reputable across the industry. So, you may see some advertisements out there for products that show massive economic differences because they may reduce disease to a small degree, and those will be using much higher literature values of disease. We wanted to use something that we really felt like we could stand behind, that the average farm is going to get, that or more, versus trying to promise, the highest possible value that's out there in the literature. So it does include everything, but it's one of the more economically conservative estimates of everything.
I guess this is a statement, but I think the question is, so there's bulls that are classified as high immunity under the current methodology, but under the new methodology are under 100%. So and that was the statement, but I think it's saying, does this occur? How can you explain that?
Mhm. So yeah, those exist, and there's really there's kind of two reasons for that. It's those are bulls that have one of two things happening. One is that they are low for those public health traits that we've incorporated. And so by blending those public health traits in, they're going to go down significantly. The second is that we've, up until today, we've branded a bull Immunity Plus when they're tested at 8 to 10 months of age, and they stay Immunity Plus the rest of their life. Even as we continue to update our reference population, run more genetic evaluations, they may have progeny that get tested, and we leave them as Immunity Plus, even as we gain more information into our genetic evaluations of Immunity Plus, of AIMer and CMER specifically. And so now with this new paradigm, we're not doing that anymore. We're going to continue to update, and you'll transparently see those evaluations over time. So it may be that they've significantly gone down for those traits, just like bulls go down significantly for other traits through their life, over time.
And I know, Stephen, there's only 23 bulls out of the 90, 23 bulls out of the 940 bulls that actually were Immunity Plus previously and went below the 100 level. And I did notice when looking at them and trying to analyze them that sometimes they're all related to the same sire. It's the sire of them that has kind of fallen in the evaluation. And then this is the little bit of the snowball effect of what made them immunity in the past and what's pulling them away from being above average immunity in the new system is what I've seen. One of the next question is, where will we find the data on immunity? CDN is the question. Semex website, Semex Works. What about older sires not on Semex Works? So I think I can answer that. It's going to be values only available via Semex. So Semex website, the solutions we offer, we will, as we go forward, the solutions will carry these parts through. We're planning a bull viewer app where you can see bulls and potentially bulls no longer in your product offering and could see the latest, the immunity value that would be there just as you would view other bulls. So that will be our source is Semex and Elevate and these components for a solution going forward. Next one is, do you have numbers on production and profitability on high immunity animals? We have seen products that boosted immune response, but they came with a cost on production or overall productivity, which resulted in companies pulling these products out of the market. Are extremely high response animals as productive?
So I guess the short answer is within this new index, we haven't directly looked at the association with production. We've looked at it in the past with Original Immunity Plus and found basically no association, meaning they weren't necessarily higher or lower. But again, the beauty of this and the power that comes with this is you can make those selection decisions alongside of this. You can create an index that's going to ensure better immune response and a measurable improvement on this immune index, as well as a measurable improvement on productivity traits. And we can create an index that has expected positive responses for both of those traits that ensures that you are both improving productivity, profitability, and immune response. And the great thing is the genetic correlation, or that I shouldn't say genetic, the proof correlation, which we expect to lead to a higher genetic correlation. The proof correlation between the new index and production traits is much higher than it was for the original index, and that's certainly a positive, ensuring that we're confident that there'll be a lot of genetics that are both high production and high immunity, and ultimately that means high profitability.
Yeah, I agree, Stephen. The plus 0.38 and plus 0.31 with fat and protein, the plus with production, and the fact that it's not antagonistic to production and seems to be something that complements well with production, I think fits into the selection index. And saying that, I mean, I agree with you that you partially love a trait that's almost antagonistic, and then finding the selection that combines, and then changing those relationships over time by building an animal that does both. So I agree with you fully.
If all of our genetic correlations get too strong, what we end up with is a whole lot of inbreeding, because we all select for the same thing. And so there is value in co-selecting traits that are not highly genetically correlated to one another.
Just a few more is there any data on the conception rates of high optimal immunity plus tested cows versus herd mates?
So again, this is something that we haven't yet looked at specifically for the optimal index, but it's something that we have looked at in the past for immunity plus, before this change. And what we found in the past that those high genomic females for immunity plus had conception rates, on average about 1% higher than herd mates who are either average or low. The public health traits we're incorporating are favorably associated with reproduction in general. And so we don't expect to lose by adding those in either. So although we haven't looked at it yet, I'm incredibly confident that the association between this new index and female reproduction will be favorable.
So I guess this one is just your reps will be going to sell immunity plus qualifying sires from one proof run, which could then not be immunity plus in the next run. This won't go down well, will it?
So I guess I'll take a first stab at that. I mean, we sell bulls who are over 1,000 for milk one proof run, who are then under 1,000 for milk the next proof run, as do all our competitors. The brand is a threshold. The brand is not a magical point in which they become great at immunity, and if they're under it, they're not. And so that's the power of having the data in front of them, is that we know that a bull who's 104 is only slightly worse than a bull who's 105. It doesn't mean that bull magically became way more immune competent than a bull who doesn't have the brand. The brand is just really an easy way for clients and our sales staff to identify bulls that we know are really strong for this trait. But bulls changing over time has always been a case. We have a whole host of other brands where bulls change over time, and gain and lose brands over time as their genetic proofs change. That's completely normal and certainly a status quo in our industry. So yes, I think there's some extension, and that's why we have these kind of conversations, is to talk about these things. But it's not a magical threshold when they get the Immunity Plus brand. It means that they're above a threshold. But that threshold is on a continuum, and just being slightly below or above a threshold on a continuum does not change how well they are translating that Immunity Plus.
And Stephen, I was thinking that, I mean, we'll see what we get, but our expectation, I think, is general stability, is because we're blending sources of these disease traits from 3 different places, and we know, our experience with the immune is it's a fairly stable from
Absolutely.
run to run. So I think we're expecting a fair stable, but the bulls right on the threshold of 105, might just get those decimal points to go below 104 or to go to 104 and then no longer get the brand. But I think one thing we're expecting is fair stability from proof to proof, is what we're expecting. Is there any correlation between low inbreeding and high immunity plus?
I would say in general that there's not, from how we run our genetic test. Certainly we know there's favorable associations between animals who are less inbred and their ability to mount an immune response. But that's not necessarily something we're able to pick up well in our additive genetic evaluation models for immunity. Because we use an additive genetic evaluation model, like every other genetic evaluation model, we don't necessarily pick up super well those animals that have more heterozygosity, meaning that they're going to be less inbred. So can avoiding inbreeding help immunity? Yes. But is this index a way to improve immunity without looking at inbreeding specifically? Also, yes. But certainly it's, something we've looked at in the past is that we are selecting favorably for alleles that are less frequent in the population in key immune regions, meaning we are selecting for heterozygosity or diversity in good places, but that doesn't mean we're going to be selecting for broad inbreeding. We are selecting for specific important inbreeding in good places, but that's not always going to lead to a better, pedigree inbreeding number of that animal.
I was thinking, Stephen, like it's like any trait, we're genetically selecting for say this immunity value, and then there's an inbreeding depression that depresses your expected gain. Is that a fair to how it would be? Yeah.
Absolutely.
So the next one is, what would be a default value? And this is our last question, is what would be a default value for mating calculations for animals with no immunity index data? What would be the default value for mating calculations for animals with no immunity index data? What do you think there?
I guess, I apologize, I'm not fully understanding this question. I think, possibly the answer is 100. Breed average for this trait would be 100. So if we're talking about mating animals and what you'd use as a default value, but in terms of how our mating program functions, I don't know that there's a default value, or if they're talking about a weight towards the index that's being used for the mating calculation, that should really be customized for the herd. I don't want to give default values. This is something that in a specific herd, in a specific country, given their economics, given the rate of disease in the herd, I don't think that there's a default value in terms of an index weight for this that I'd want to give broadly to the whole world. I think that's something that we really want to work on being custom. And the more we can get to those customized type indexes, that, the more power of selection, the more we're going to get the right bulls to the right clients. And we're going to avoid global inbreeding by doing that, because the more diverse our selection indexes are from herd to herd to herd, the less inbreeding we're going to have, in the global Holstein population, and that's a good thing too. So I'm always just going to be the one, in this type of forum that's going to tell you custom index, and nothing should be default across herd to herd. Things shouldn't be default, things should be custom.
And Stephen, the percentage of just remind me the question again. I'm sorry, I was thinking about two different things.
The default weight of the immunity index.
So I think our plan is to take what your economics are of the value of immunity, and then what's the economics of all other traits, and then obviously we have correlation of traits in terms of immunity to other things in the index. But I know that our plan is to come up with, and I want to say default, but almost a base value of what is immunity worth. Now, obviously that gets customized on an index, but I think you're going to see some work done to try to help clients get there to how they incorporate it and maintain the overall improvement to what they're looking for down the road. So we did get one fast question there. What impact do you think alligator suns will have on immunity? I'm not sure if we can answer that one. So I'm going to leave that. Do you deliver individual traits if the farmer have different economic costs? Do you deliver data for individual traits if the farmer has different economical costs?
So the short answer there is no. We aren't going to be delivering individual traits. I think they're talking about, AIMer, CIMer, and then the individual public health traits are public and available, certainly. But we aren't going to be delivering AIMer and CIMer. We feel pretty confidently that the way they're weighted in this, index is going to perform well for all farms, given how broad of a data set we used to create this. We used a very large global data set, and so we feel confident in that way that it will be incredibly robust to different economics in terms of, in terms of individual disease frequencies from one farm to the next. But certainly how that's then combined with the other broad economic things on farm, milk, reproduction, conformation, that's a much different discussion.
And I think we're gonna cut off here, but I wanted to first say that, well, I mean, thank you for all those questions and the interest and the keen interest, and so, I mean, and many of those, I mean, were just great questions and great parts in terms of I think you picked up a lot of what is the value and what is the power that we're bringing to the market here with the index. So wanted to thank again everyone for their tremendous feedback and everything that you've done in this webinar. So next week we have another one. So it's proof week next week. The proofs are on Tuesday, I think it's the 9th, Stephen. And then what we do every proof week is we follow up at the end of the week and do SIRE summary news. This is where we hear from our experts, Paul Trabb, Mike West, Jonathan Merriam, in terms of our Holstein and Jersey lineups. We'll give a little reiteration of immunity and some of the things we saw with our first official run with immunity, but register for the webinar. Even if you can't attend, you get a video copy of the webinar. So we encourage you to register for the webinar, which you can do online at Semex.com. So with that, Stephen, again, thank you very much. You carried the load. Really appreciate it. And thank you everyone for your attendance, and have a great day.
Thanks, everyone.